So anyway, thank you all for coming this evening. Meetup number 68. We've got a big crowd here tonight, so we'll keep it short and sweet. Sorry for starting a bit late. Mitch and his technical difficulties, but I think we've sorted them all now. But we'll see how it goes. Just thank you to our sponsors tonight. So we have Palo Alto and Telstra are talking tonight. Thank you to our sponsors, they make this happen. So they help us to set this up and run this on a monthly basis. So thank you all, without it, it wouldn't happen. So cheers for the sponsors. Up tonight we have, for introduction, we have Mitch, who's going from AWS, who's hiding behind a pillar. He's actually here, I promise. So Mitch is going to give us an introduction into Fargate, and then we're going to have session 1, which is Mauricio from Palo. He's going to give us a talk on automated security management on AWS. There's Mauricio there, who just appeared from nowhere. And then we're going to break and do some networking. You're all going to have some good conversations, as you do, yes? And then we're going to roll into cloud with Bobby, who's talking about automating the service desk using Amazon Lex and Amazon Connect. Who here is using Lex or Connect currently? Anyone? Anyone? 1, 2, maybe? Cool. All right, and then we'll wrap it up with the door prizes for tonight. Has everybody here signed in? So to sign in to get into the door prize, which is the Amazon Dot, which comes from PolarSeven, and then Palo Alto have this Beats pill here. Has everyone filled out a form? So there's a form here which you can fill it out at the break, put it into the beautiful green bucket, which matches the brochureware. Yeah, so it was a good find. Yeah, good stuff. And then we'll do that at the end of the evening. So without further ado, I'll just hand over to Mitch, who's going to give us a AWS Fargate in 15 minutes, which we're going to time. So can everybody get their timer out and make sure it's 15 minutes from now. No pressure, Mitch.
Okay, thank you.
And I have to hold the microphone.
Right, here we go. Good evening, everybody. I'm Mitch. I work for AWS, a solutions architect based here in Sydney. Who here uses containers for anything and everything? Fantastic, great. Who here has used ECS for orchestrating those containers at scale? Great. Who doesn't know what ECS is? Who doesn't know what containers are? Okay, so I don't need to go into too much of the basics around that.
Clear as line.
Yeah. So I've got a couple of options for delivering the content I was going to deliver tonight. The first one was going to be a presentation, or the other one was going to be a demo. I'm edging towards demo at the minute. Would anyone really like me to do 15 minutes of boring PowerPoint slides?
No hands.
Great. And it's also a bonus session as well. I think on the meeting website, it's a bonus session, so I thought I should do a bit of bonus work here as well. So I'm also going to be showing you our Cloud9 IDE solution. Everyone know what that is? Anyone come across that before? Great, cool. So it's a hosted IDE solution for you to do all sorts of interesting things from an AWS perspective, including developing your applications and integrating with the native services as well. Sorry, is that too small?
Sorry? You can't see?
Just zoom in. Yeah.
Oh, zoom in.
Not out.
Zoom in.
Is that any better? Thank you. I'll try that. Cool. All right, great. So, first and foremost,
sorry, feel free to walk up and get closer if you guys want to.
So we've had ECS floating around in a while now for about 3 years, and we built ECS with the prime initial purpose of helping customers deploy containers across a fleet of EC2 instances and manage the resources across those instances and take care of all the scheduling of those containers across those instances for us. And so the primary focus was around coordinating the resources. What that meant, though, was that as people brought more containers to the party, we ended up having more EC2 instances. So those of you that have deployed ECS before in the past will understand and appreciate that ECS doesn't come without its complexities. Primarily, they tend to stick around the EC2 instance level, so you've got EC2 instances that you need to manage, that you need to coordinate and patch and monitor, but also things like auto-scaling. So how do you configure your auto-scaling of your EC2 instances to reflect changes in load for your application itself? Because you have these kind of two substrates. You've got the EC2 layer, and then you've also got the container layer as well. And that was the feedback that we got from lots of our customers. It's too difficult, there's too many instances to manage, and as we scale, it just becomes impossible to manage. So that's where Fargate was born. So Fargate, contrary to some of the confusion I've heard customers share with me, it isn't a new service. It's a capability, or it's a technology, or it's a feature that we've built that is accessible and available to someone that is using ECS. So in the past, when you deployed an ECS cluster, you had the option to create EC2 instances and deploy your tasks onto those EC2 instances. Now what you do is you have the ability with Fargate to deploy your tasks onto a Fargate cluster. So we consider them to be different launch types. So you have an EC2 launch type and a Fargate launch type. That is to say you launch your containers into EC2 or you launch them into Fargate. Now under the covers, they are all essentially the same thing. The big difference is that Fargate launch type, we take care of the EC2 instances for you. So there's no EC2 instances for you to manage. We manage them for you. When you deploy tasks into those clusters, we will provision network interfaces, backend infrastructure for you, and wire them into your VPC so that those tasks or containers then can interact with the services across your environment or be attached to things like load balancers that exist within your environment. Make sense? Excellent. So let's start with a quick demo of how this all kind of hangs together. So in good old demo style, I repopulated all my demo commands because I'm going to forget half of them. So the first thing we do when we're deploying Fargate is we create a Fargate cluster. Actually, we create an ECS cluster. There's nothing different really from a Fargate perspective. A Fargate cluster versus an ECS cluster. We just bring up there. So what you'll see in a second is I've created a cluster. And I'll switch to the right region. Apologies. So to point out here, Fargate is currently only available in US, in our East one, US East 1 region. So here already what I've done is I've created a Fargate cluster now with that simple CLI command. I could have done that through the GUI as well. It's a very easy wizard process, but I wanted to do it through the CLI because CLI is also agreed? Yes, thank you. So first and foremost, I've created my cluster. What you'll see then is I've got two kind of cluster options here. I've got all cluster types. I've got a Fargate option and an EC2 option. The cool thing about Fargate is it's not either or. It is we can use Fargate in conjunction with EC2, which means that if we've already invested in something like reserved instances or we want to use spot instances, we can continue to use those with our standard EC2 launch type, but we might decide to use Fargate launch tasks for scaling. It's a lot quicker to scale 1,000 tasks than it is to scale the underlying infrastructure and then a whole bunch of tasks on top of those, if that makes sense. So if you're in a need to really quickly scale up your environment, Fargate's a really good option, so you can kind of bleed over into the Fargate and scale down when you need to. So I've created my cluster. Next step for me is to register what we call a task definition. So a task definition essentially defines what my application needs to look like. There we go, I've created my task definition now. I'm going to go and list my task definitions quickly. Can everyone see the console there? Okay. So I've created my task definitions, and as you can see, I've created a new task definition here called Fargate 8. So that task definition essentially says that I have created a task, which is a logical construct or collection of containers. Those containers can talk to each other. They share what we call a namespace, several namespaces in container world. They essentially share a network routing table, a network IP address, resources, such as CPU and memory, and they can essentially talk to each other over that local area network as well, or sorry, that local host network namespace that exists there. So the next thing for me to do then is, once I've created my task definition, I would show you the task definition, but the screen's clearly too small for that, so I don't want to strain your eyes too much. Now what I'm going to do is I'm going to create a sorry, I'm going to list my task definitions first again, so I'm going to check which number we have. It's my task definitions. So I've got revision number 8 here, so I'm just going to grab that one. As you can see, I've tested my demo several times, as any good demo would do, so I've made sure it's working. So I'm just going to update this command here. So what this is going to do for me now is essentially expose my task or my application to the outside world. So by creating what we call a service, which is essentially a construct and abstract away from the tasks themselves, I'm instructing ECS that I want to have a set number of tasks running to be exposed to the outside world over an IP address or via a load balancer. So by creating a task, I'm creating a single kind of managed entity. By creating a service, I'm creating an abstraction layer over the number of tasks and saying I want to have minimum 20 tasks, minimum 30 tasks, and I want to attach a load balancer in front of those tasks. ECS then takes care of all that hard wiring in terms of making sure that the load balancer knows which of those managed container instances host tasks that my load balancer needs to connect to. Just a quick pull up on that. Is everyone clear on the difference between tasks and containers? Hands up if you're not sure what I'm talking about when we talk about tasks and containers. Right, excellent. Right. So what you'll see I've done now, by just running those few simple commands there, is I've been able to spin up a service, and I've got 2 tasks running at the minute as well. These are all running under Fargate. Let's have a quick look at what that actually means. We've got a Fargate service here. That Fargate service sits behind a load balancer. So my load balancer target group is here. Those of you familiar with application load balancers, that will make sense, but it's not really relevant for the demo that we're doing right now. Here are my tasks. So these are the 2 tasks that I've defined within my task definition. It's created 2 tasks for me, running this version of task definition and running a very specific container that I stored in Docker for deployment. So let me go now and grab the URL for my task, which I know to be Fargate. What's going to happen? There we go. So that's deployed my application for me now. Unfortunately, I wasn't able to show you that it wasn't there to start with. But what you can see is I've very quickly been able to deploy an application without actually doing anything from a server perspective. Yeah, so I've not got involved in any server configurations. If we look at the cluster itself, come back here. So if we look at the configuration here, what you can see is I've got no EC2 instance, which is kind of really interesting. For those of you that have played with ECS in the past, you'll be expecting to see lots of EC2 instances there, and each of those EC2 instances needs care and attention on a daily basis. You've got to monitor the metrics, you've got to monitor its utilization, and you've got to make sure that you have enough of those EC2 instances to manage and support the number of containers that you want to cluster requirement. The great thing about Fargate technology that we now apply to ECS is that those concerns are now kind of abstracted away from you. So there's no need for you to actually go in there and manage those EC2 instances anymore. If we're not managing EC2 instances, how are we pricing Fargate? Interesting question. Do we charge by the EC2 instances that we don't see? Do we charge by some dimension that we're not familiar with? No, we charge by the resources that your tasks use. So if we flip back to the, not that way. If we flip back to Cloud9 and just do a quick look at the Fargate task pitch right here, I'll bring that up so you can see it. What you can see down here at the bottom, hopefully it's not too small, is I've specified some resources. So I've specified CPU and I've specified memory. That is what I pay for when I run a task using Fargate. I pay per second for the resources that I've used. It's quite a powerful concept, especially if you start to think about short-run batch jobs or the ability to scale very quickly in case of a big demand on a website. So rather than paying for a full EC2 instance, waiting for that EC2 instance to spin up and then loading it with containers and potentially underutilizing that EC2 instance, what you're now doing is you're deploying containers, you're paying for the actual utilization, which is 100% essentially. You're using 100% of the resources that you provision. And you're able to scale that back down again when you finish with it, and then you're paying on a per second basis for what you're actually consuming. Make sense? Excellent, fantastic. Sorry. Yeah.
256 CPU.
Yeah.
What is this 256?
Sorry. That was. It's a. Go back to the meters there a second. What have we got there? 256 CPU. So it's like a quarter of a CPU.
Quarter of a CPU.
Yeah. But you could put that as, for example, 0.25 vCPU. So you could there's a few ways that you can enter that information there. So you can specify it as an integer like that, or you can specify it as a string. So, or you can put it as a 0.25 vCPU. You can put it as here down here. So we could do 0.5. Oops, not there. We can do 0.5 GB gigabytes.
Okay. Yeah, right, because I thought it was the number of cores.
Yeah, that would be pretty awesome container. Yeah, and fairly expensive as well, I'd imagine. But yeah, so you specify the traits that you want. So essentially, we have about 50 pre-configured configurations, predetermined configurations of tasks from a resource perspective that you can choose from. And essentially, it matches and marries up to every single type of connotation that you may want to work from a resource perspective. You specify those metrics, those resources here within the task definition. You deploy the task, and the rest is dealt with at the CFO level when it gets to build the individual. That was me doing my demo really quickly. I've got 1 minute 50 seconds left. I'm opening to questions. I am going to be here for a while, so I can stick around.
I would like to know if the EC2 instances are shared.
Good question. No, they're not. No. So we have a concept called cluster, which everyone's familiar with if you've already been using ECS. When you create a cluster, the applications that you deploy within that cluster will share infrastructure within that cluster. If you create 2 clusters, so let's say you created a dev and a test cluster, if you deployed your applications to your dev cluster, they would not bleed into your test cluster or your production cluster. So we isolate workloads at the cluster level.
Because you don't define the EC2 instance here.
Yeah, exactly.
But
yeah. So that's why we have this concept still called a cluster. So we tell with Fargate was a big reason for Fargate, and one of the big selling points of Fargate was to eliminate the heavy lifting of managing a complex cluster. What you'll notice is that we still have this construct called a cluster, and the reason we have that is for that security boundary. So that anything you deploy within a given cluster is isolated at the EC2 level, but also at a security level from anything else that comes. Make sense?
Yeah.
Perfect. Any other? Yes, sir.
Estimate about availability of Fargate.
Sorry?
Do you know anything about the availability of Fargate at Sydney region?
Great question. Wonderful question. No. What I would say is the best thing to do is if you have a relationship already with a solutions architect or technical account manager or someone within AWS, make it known that you really, really want that service here. That's what I do on a daily basis. There's a few people I work with here on a regular basis, and I'm always taking that in from time to time. I'm taking that feedback into our service teams and making it known that we want that service here as quickly as possible. So that's let me log out. I know what you're going to do. So yeah, just make sure that make sure that the account team that you work with is aware that you've got a requirement to use it, and make sure we feed that back into it's fed back into AWS. And even if you use the support console, go to the support console and provide feedback that way. Service or feature requests is a really good way to do that. And I would encourage everyone here that's got a vested interest in a little thing called EKS, which is our managed Kubernetes service. Do that, log into the console, open a ticket, feature request. I'd love to see EKS here in Sydney as quickly as possible. And that really does help move things along from a prioritization perspective. One thing I forgot to mention there is that EKS, which is our managed Kubernetes service, will at some point this year as well also include the Fargate capability. So it's not a capability that's unique to ECS. So imagine those of you who's ever set up a Kubernetes cluster in the past. Yeah, so painful, right? So imagine having a lot of that heavy lifting that's associated with deploying a Kubernetes cluster abstracted away by EKS, but then also the worker nodes that perform the heavy lifting of your Kubernetes deployment extracted away using Fargate. That's the utopia that we're heading for. So if that's something you'd like to see here, I encourage you to log that.
Last question.
Yeah.
Last question, please. If let's say if I push a new version or new tag version of my image, and I want to do blue-green deployment, is it supported by Fargate?
So blue-green, the native way that ECS does deployments is rolling deployments. So when you create a service, you will specify a minimum healthy percentage and a maximum healthy percentage of containers. So if you had 100% and you already had 2 containers, we'd add another 2 containers, we would upgrade the new two new containers, and then when they were good to go, we would kill off the 2 legacy containers. It's not really blue-green. So to have a more sophisticated blue-green rollback capability.
Right.
That is not a native feature of ECS, but it is something that can be easily achieved through looking at tools like code pipeline and code deployment. So there's plenty of reference architectures on the
so you have to work around it.
Yeah, exactly. Yeah, it's working exactly. Yeah. But what I would say is it's a common ask from customers to have that native capability, and we've listened. So provide the feedback through the console. Don't be surprised if something along those lines gets talked about at some point in the not too distant future.
Thank you very much.
Cool.
Excellent.
I'll be hanging around all evening, so if you want to ask me more, feel free to do so.
Great. Mitch, thank you very much. Thank you very much, Mitch. And up now we have Robert. Did I say it right?
No, Mauricio.
Or Mauricio. Pretty close. Close enough? Okay.
You can take more. So, that was a great demo, by the way. I think I learned something. But unfortunately for you, this is going to be the boring PowerPoint presentation. I just found out yesterday I need to do this presentation because our cloud consulting engineer had an issue that couldn't attend. So hopefully this is going to be enough to trigger the interest, so then you want to know more, and then we can do the actual demo or POC, etc. So basically just going to go into the secure AWS and public cloud workloads, and want to do mainly focus on automation, and hopefully we have time for Q&A at the end. So this part, of course, you know it already. That's why you're here. You know that a lot of the data and information is going into the cloud as infrastructure as a service, and also as platform as a service, and software as a service as well. So it's becoming more and more complex to protect your information. Now, I'm not going to spend much time on that. You know it already, but I thought it was important to put it there. So applying security on the cloud is quite challenging. There are many reasons for that. First is fragmented security, where each cloud provider will have their own kind of security or security tools that they provide, but they're going to be very different to what you're using on premises, and very different to what you need to use on SaaS as well. So it is quite challenging with the fragmented security. Also manual security. Many of the things you do are going to be automated by default, like the security groups, but whenever you try to do a little bit over that, it's going to be manual. So that introduces a lot of human error. So we think it is important to, first of all, always have the advanced application visibility and control, and that data breach prevention on every environment. So you shouldn't need to compromise security because you're going to the cloud. Going to the cloud has a lot of benefits, but you shouldn't need to compromise on security because of that. It has to be consistent across all the locations, so make sure that that same protection that you can apply on your data center can go into the cloud. And that doesn't mean it has to be exactly the same product deployed the same way, but you want to make sure that you have a consistent security policy across all of them. And of course, if it's not frictionless, it's not easy to deploy, you're not going to do it, because that's the whole reason you're going to cloud, because it's easy, it's scalable. If you don't do the same with security, you're just not going to apply it. Now, just as a reminder, I'm sure you all know this very well, which is the shared security model. Just to remind you, this is what Amazon takes care of, which is protecting their infrastructure. All the rest is up to you. Provide some tools, which are great base controls, but it's always you need to remember that it's up to you to secure your data. I've seen many customers that they say, oh no, but it's in the cloud, it's secure because AWS is protecting it. Well, no, it's not the case. You need to remember it's your responsibility. So the way we see it, there are three key points where we're going to apply security, where we can help you secure your environment. The first one, which is the one that most people are aware of, at least when they think about Palo Alto Networks, is inline security, which of course is important, but it's not the only one. And I'm going to cover that in a minute a little bit more. The second one is on the host. I'm sure a lot of you are already running some kind of host protections on your environments, but we still believe that it's key to have it on all the workloads that are running there. Whatever operating system it is, it has to be protected. And the last one that is not really top of mind of every customer, but I think it should be, is all the security that we can apply through the API, especially into the platform as a service, and controlling what you are doing on all those cloud environments. So if we look at a little bit of a summary, and there's a lot of things that are not included here, you can see that the first 2 points, like account management and data governance, can be done through the API. And that's where, for things like key rotation, making sure you're using multi-factor authentication, running compliance reports, discovering all the resources that you're running, making sure that you don't have any data exposed on your S3 buckets, for example, that can be very easily done through the API. Because AWS has a great set of APIs exposed that we can use to find that information for you. They have some, for example, some great top 10 security recommendations that you should run on your environment, but you have no easy way to see if you're meeting those top 20 recommendations. So being able to run a report by just tapping into the API and getting all the information and seeing if you are doing the best practice and help you get there is something we can easily do. We do all that with a product called Aperture, which is basically the same we use for all the SaaS application security, but since the infrastructure used to control SaaS is the same that we can use to leverage the API for AWS, we thought, why not do it and add that extra layer of security. And then, of course, all the to be able to segment all your applications on the cloud and prevent malware, all the attacks, apply IPS, etc. So, I started by saying before, AWS is providing the security groups that you can do some controls, which is great, but I wanted to spend a couple of minutes on what's the difference between that and what we can provide that we've been doing for many years on your physical data center. So let's look at the flow. We know the source IP, destination IP, the port, the amount of data. That's typically what you're going to see on most of the cloud security services. That doesn't mean anything. It means you've got a connection. That's it. Now, if you start looking a little bit more on the details, you see who the user is, what the protocol is, because the fact that it's 443 doesn't mean that it's going to be an SSL there. And that port could be anything else. Someone can take control of that server and change what is being published in there. You can see what is the source or destination country where that connection is coming from. And if you keep looking, you can see what the content is, what the application is, what the application component is, what the file that is being transferred is, what is the group of that user belongs to. And that becomes very relevant for you to make a decision if it has to be allowed or not. And that's what we believe is really key to take that to the cloud. I mean, now and today, things of putting an ACL on a switch as the security on the data center. Why would you do the same on a cloud environment? You really need to understand what's happening there so then you can control it.
Maybe a stupid question,
yes.
If you don't mind. If we have HTTPS,
yes.
Let's say if this SSL thing is done properly,
yep.
How can you work out the content type?
So SSL can be decrypted. Inbound or outbound decryption, it is possible. You do need to have the certificate of that, either the server or the certificate that is on the load balancer to be able to do it. But
okay, so you're in the instance level, and if the instance level is in HTTP, then you can figure it out.
So this is inline security, it's seeing the traffic, and we can use a certificate that is being used for the encryption to decrypt that traffic and see what's inside. Happy to, when we finish this, to go into more detail, but we can do all the decryption, of course. Now, I wanted to spend a couple of minutes on automation. And automation means different things for different people. And I wanted to talk about 3 different types of automations here. The first one, of course, is the automation within our platform. So we provide security on multiple environments, including what we said before, inline, the data center, the cloud, and the endpoint. But we need to make sure that we leverage all the information and data that we get from all the environments across all the customers to make security better. And the way we do that is by using cloud delivered services, where we take new malware and new information and telemetry from all our customers, and we send that into the cloud to find new threats and automatically update the security on all the components. Also leveraging third-party feeds, including the Cybersecurity Threat Alliance, and even the new Amazon Guard Duty. So a lot of information going into our cloud delivery service to make sure that you always have the latest protection for your environment. Now, the second part of our automation is more on the management side. I mentioned as one of the 3 key components of cloud security is make it frictionless, make it easy to deploy, and management is one of them. You don't want to be in the position where you launch a new task or a new instance, and then you need to submit a request to security to update the security policy, and that's going to take a couple of weeks, because that's not going to fly, and you're going to compromise on the security to be able to have the agility. So with this, we have the concept of dynamic address groups, which basically gets all the tags that you can apply to your instances and turn it into a dynamic group on the firewall. So basically here you have the definition of one of the dynamic groups, where you say if it has this tag and that tag, it belongs to the group. So every time you launch a new instance, and it has some tags that are the default ones, plus the manual ones that you can add, it will automatically belong to the group and get the security policy. That means you only need to add or touch the security policy whenever there is a new service that you want to allow. But whenever it's just adding new instances to current rules, there is no need to do any changes at all on the security policy. Now, the third type of automation is being able to deploy and configure this automatically. So we started supporting this a few years back, but this is the first time we have an official supported CloudFormation template, version 2.0, after a couple of iterations. This is a great template that has 2 components. The first one, to deploy the top layer, which is the ALB layer, and the firewall layer using auto-scaling groups, which allows you to automatically scale based on need. And the second template is doing the bottom layer with the NLVs and all your applications. Now, the first one is the one that is officially supported by Palo Alto Networks, which means if you have any problem running it, you can call our support and we'll help you make sure it's done correctly. We also have all the instructions published on how to manage or modify these templates to apply to your environment. So this is not something that we give you a script saying this is a proof of concept, we saw it running one time, good luck. No, we're actually helping you create this CloudFormation template to make sure you can deploy this very, very easily. This can be done across a single VPC, multiple VPCs, single account, multiple accounts. And with this kind of infrastructure, you can scale as much as you need. Now, you might want to look at tools like Terraform or Ansible to orchestrate this for several reasons. One is with the CloudFormation template, we will do the bootstrapping for the configuration, but that means you need to have the configuration preset on the S3 bucket. With Terraform, since we launched the new provider, that's become a lot easier. So up until a few days ago, we were basically doing something similar than the CloudFormation template, where you had to create a bootstrapping file, put it on an S3 bucket, and then from Terraform launch the template. And you had to use other tools like Vagrant for doing the configuration, because Terraform couldn't do it all together. But now with the new Terraform provider that we launched, you can do it all in one single component. There's no need for bootstrapping, and there's no restrictions there. So if I look at what it was before, you had to define your bootstrapping, create the files, put all your configuration for your nets and basic setup. But then again, all the information had to be pre-done on the bootstrapping file. Now with the new one, it's very easy to provision new firewalls, new instances, where you just say how do you want it to be named, what do you want the username, password to be defined, and then all the configuration, including all the security policies, can be pushed directly from Terraform. So it makes it very, very easy to automate your security, so you don't need to compromise anymore. You can have the agility, but still have all the security and all the visibility as well. Last one, there's a lot more templates. I mentioned before the one that is actually officially supported, but there are a lot that are just to help you with some ideas on things that you can achieve that are not going to be officially supported, but they do work, and you can leverage it to create your own scripts. So please go to our GitHub page, and you'll find a lot of interesting information there. Hope you can play around with that and launch a few of these environments. Since all the files are also charged per hour of use only, you can easily play with this and only spend a few dollars. Also wanted to mention we have our user conference coming up. So if you want to attend to this, please let us know and we can work with you to get you there. And also encourage you to join our user group. If you're a user group, we also do similar meetups like here, probably not as big as this, and hopefully we'll get to this size soon. But it's a great place for all Palo Alto Networks customers to share information among each other. Thank you, and sorry again for the presentation. Questions?
Questions?
Yes.
Do you do PCI and PII compliance sort of thing?
So, can you repeat it? Because you
we need to comply with PCI compliance, you know.
Yes.
And then PII is coming like this May.
Yes.
And then I'm not sure if you guys have some scanning about, you know, some sort of
definitely.
So, or whatever.
There are two ways you can achieve that. One is with the inline security by controlling the files going in and out, and we can check for credit card information, personal information on the flow. And the other is through the API, you will actually look at all the files stored on your buckets to see what type of information they have, and based on that, decide the level of sharing that they can have. So both with the inline and with the API, at different use cases.
The 200 boxes like by scanning.
Yes, it will automatically scan all your data and tell you which ones have personal information, which ones have credit card information. I will tell you who it's been shared with, who have accessed that before as well. So all in a very nice console, which, by the way, is the same console that you would use for all your SaaS applications. So it's not just limited to AWS, but if you have like Salesforce or you have a Dropbox for your files, as well, it's going to be all part of the same console. So yes.
Other questions? No questions? Excellent. Thank you again very much. That was great. Thank you very much. Thank you. We're going to refresh your drink. Keep calm. It's a big time.